Hello, we are discussing about GATE 2007 ECE paper, and this question is related to digital circuits. Look at the diagram given. The diagram is digital to analog converter, that is R to R digital to analog converter. In the digital to analog converter circuit shown, VR is equal to 10 volts and R is equal to 10 kilo ohms. R value is given as 10 kilo ohms and the reference voltage is 10 volts. Then the current I flowing through the circuit. I is nothing but this value. What is the current flowing through this 2R resistor? And next, what is the output voltage V0? These two are going to be linked questions. So the output voltage and the current flowing through this 2R, both we are going to calculate. Okay, so this can be calculated in this way, and it is op amp circuit, and this op amp is going to be assume it as ideal. If you assume this is nothing is given about the op amp, so you can directly assume it as op amp is ideal. Whenever op amp is ideal at that time, okay, for ideal op amp AV is equal to infinite, voltage gain is infinite, that makes input difference has to be 0. Ideal op amp is going to be having a characteristics AV is equal to infinite. AV implies nothing but output voltage divided by input voltage. Input voltage is nothing but difference between the inputs. So from this one you can write it as VID is equal to V0 divided by A, that is nothing but V0 divided by infinite, which is nothing but 0. That 0 is nothing but VID, which is nothing but V plus minus V minus. Voltage at non-inverting terminal minus voltage at inverting terminal. So V plus minus V minus is equal to 0. That is going to be making V plus is equal to V minus whenever AV is infinite. This is going to be called as virtual short situation. Virtual short situation. So whenever one of the terminal voltage is going to be known, at that time the other terminal is also at the same voltage. Both the terminals are at the same voltage, that is the meaning. So since V plus is going to be connected at 0 volts, so this is also at 0 volts, that is nothing but same ground. This can be also treated as ground. Okay, and now look at this one. Assume that one this is node A, and this is from node A to ground there is a resistance of 2R. From node A to ground there is a resistance of 2R. So voltage at node A is going to be same voltage for this 2R, same voltage for this 2R. That implies nothing but same current has to flow through this I, that is same current has to flow through this 2R, so that this is also I. So current flowing through this R is going to be treated as 2I. 2I is the current flowing through this R. Okay, and let us assume this is the node B. This is node B now. This is node B. From node B towards ground, this is 2R, and if you are going to be checking about the effective resistance across this B to ground this side, at that time it is 2R and 2R, they are in parallel, so that these two are in parallel, so that 2R parallel to R is nothing but R only you will get. So this R and this R will be in series, so R plus R will be 2R. So again the effective resistance from B to ground is 2R. Here also the effective resistance is 2R only. Since we know the current flowing through this one is 2I, the same current is also flows through this trace resistor. Because these two are in parallel, voltages are going to be same, resistances are also same, so that same current flows. So in this 2R resistor the current flowing is 2I, and current flowing through this R is going to be treated as 4I now. Whenever it is 4I, and the effective, assume that one this is the node C. Okay, this is node C. Node C. This node C is nothing but from this one node C to towards this ground. At that time it is effective resistance is 2R, and here also you will get the effective resistance as 2R towards ground. So that since the current flowing through is 4I, again you are going to get the same 4I in this one. Okay, because effective resistance in the above branch and this branch is going to be same as 2R, voltage is same, current resistance is same, so that you will get the same currents in both branches. So 4I, the total is nothing but 8I is the current flowing through this R. is the current flowing through. This one is nothing but 8I. And again the same thing is going to be taking place. Effective resistance is same, so that 8I, the current coming from this one is nothing but 16I. Okay. And if you are going in this way, at that time the equivalent uh, circuit can be written in this way. The equivalent resistance is nothing but VR. Okay, VR, that is nothing but plus minus. VR is given as 10 volts, and here the current coming from this one is nothing but 16I, and the effective resistance, this is 1 is 2R, where 8I is going to be the current, and other effective resistance is again 2R, that is another 8I is going with. So these two are in parallel, so that you can write it as a simple single resistor with with 10 volts battery, and the resistance value is 2R. Parallel to R is nothing but R, and the current flowing through this is nothing but 16I. R value is given as 10 kilo ohms. So from this one we can calculate it as 16I is equal to V by R, which is nothing but 10 volts divided by 10 kilo ohms, which is nothing but 10 milliamperes. Sorry, 1 milliampere. It is not 10, it is only 1 milliampere. 10 by 10 kilo ohm is nothing but 1 milliampere. So I is equal to 1 by 16 milliamperes. 1 by 16 milliamperes is nothing but, the answer is 62.5 microamperes. 62.5 microamperes is the current. So the required value of I in 2R is nothing but 62.5 microamperes. Okay. And now V0, if you want to calculate, V0 is nothing but voltage from V0 node to ground. Voltage from V0 node to ground is nothing but V0. So that is nothing but V0 is this one. From this node towards ground is nothing but this one. So if you know the current flowing through this one, assume that one current is flowing in this one, because no current flowing through internal nodes. So whatever the current coming in this way, the currents are coming in this way, the currents are gets added, the same current is flowing through this R. By that time assume that one this is capital I, whereas previous one is small I. Otherwise you can go with I1. V0 is equal to, we can write it as minus I1 into R. Generally current flows from higher positive voltage to lower positive voltage, that is higher voltage to lower voltage. But here the current is coming in different direction, low voltage to high voltage. Okay. So V0 is equal to minus I1 into R. So I1 can be written as V0 is equal to minus I1 times of R, and I1 is nothing but current flowing through this branch, that is I. Current flowing through this branch is I, and current flowing through this branch is nothing but 4I. So total is I plus 4I is nothing but 5I. So this can be written as 5 times of I into R. So minus 5 times of 62.5 into R is nothing but 10 kilo ohms. 10 kilo ohms. So the V0 value what you are going to get is nothing but 3.125 volts. Minus 3.125 volts is going to be the answer for V0, whereas I is equal to 62.5 microamperes. So here the right answers are going to be, current I is 62.5 microamperes, so that it is B is the right answer. Voltage V0 is nothing but minus 3.125, which is nothing but C is the right answer. Thank you.